All right, well, welcome back to the last University of Idaho, Utah State University, and South Dakota State University Extension Sheep and Goat webinar of the year. And so I'm Melinda Ellison with the University of Idaho. I'm the sheep specialist. We also have Chad Page on today, who is a co-host for this webinar series. He is the Extension Small Ruminant Specialist for Utah State University. And not with us today, but also co-hosts are Carmen Wilmore with the University of Idaho and Jaylyn Whaley with South Dakota State University. So we welcome you back to the monthly webinar. And today we're really lucky to have Rebecca Kern-Lumberry, who is with Ward Laboratories. So for all of you who ask us questions about where to get your feed and water samples analyzed and who can take those and do a great job with them, she is one of the best. And so we're really excited to have her on to share with you some of the when and why and how of analyzing feed and water for your sheep and goats, as well as she is one of the best interpreters that I know and does a really great job with that. So that's why she's here today. And thank you very much for joining us. And I'll let you take it away from here.
Great. Thank you so much for having me, and thanks for the kind words, Melinda. That's really means a lot and very nice. So I'm gonna talk a bit about forage and water analysis today. So in the past, I have been on this webinar with Melinda and Carmen, and that did focus more on proper sampling. So you can go back to those webinars for that, or you can check out Ward Lab's website for proper sampling procedures. And of course, I'm always just a phone call away, actually, to help guide producers through that. So today I'm going to switch it up a little bit, and we're going to talk a little bit about how sheep and goat anatomy is very different from the cattle anatomy, because a lot of times when it comes to report interpretation and the guides that you'll find out on the internet, it's very much focused for beef cattle or dairy cattle, but ultimately these are very different animals, and so you do need to keep some different things in mind as you go through your report. Then the meat and potatoes is really going to be understanding I'm going to go through each constituent and parameter that you would get on an NIRS forage report, and just kind of helping understand why each of these parameters is important, because sometimes producers will get a report and it just seems very overwhelming. And then at the end, we'll look at a report and evaluate what that report means for a specific animal. And then I'm going to go through understanding a water report at the end, and that'll be pretty brief. So first to jump in, and I think a lot of you guys, being sheep and goat producers, probably already know a lot of this, right? And so we know cattle are big grazers, right? Whatever you put in front of them, they're going to use their big mouth and they're just going to grab as much as they can. They have the large gut capacity. They're going to eat as much as they can, and they're going to go back, they're going to bed down, and they're going to ruminate. And of course, sheep and goats are also ruminant species, so they're going to also consume what's in front of them, go back and ruminate. However, they have a very different design, specifically goats being true browsers. They're going to be a lot more selective. They're not just going to go through and grab whatever grass is. So their natural behavior is very different from beef cattle. And so we need to think about how does that natural behavior impact their needs when we're talking about forages that are fed to them when they're in confinement, whether it be due to winter months or just, lack of grazing opportunities. And then sheep are considered an intermediate feeder, so they fall somewhere between the goats and the cattle. And so I have a lot of text here on this slide, but I've thrown up here a photo to hopefully kind of cut through that. So you can kind of see that it's a spectrum, right? So we have our big grazers, cattle, bison, and then we have our more selective animals. This is where we see goats and deer. And so relative to their body weight, grazers have larger guts. So the rumen and reticulum are making up to 30% of their body weight when we're talking about cattle, versus a goat, it's going to be between 10 and 15% of their body weight. And so they're going out, they're being more selective. They have a smaller gut capacity. This means that they don't have the tolerance for a high fiber diet that beef cow does. And so when we're looking at a hay report, that's something we're going to want to really consider. And so a lot of the comparative anatomy comes with a, their lips are more agile, and they're, better able to like grab things versus a cow. They have that narrower muzzle, smaller body, smaller gut. So their frequency of feeding also is very different than a beef cow, right? And so beef cows really only need to consume feed 2 to 3 times a day, whereas sheep and goats probably need a more frequent feeding, or at least to have feed available um, to them for more time periods, right? Um, so, so what does this mean when we look at the forage report, if we're sampling our hays or, other forages, is compared to the beef cow, we want to see lower fibers and higher protein. And so this is reflected when we look at our NRC animal nutrient requirements, whether it's for sheep or for goats. And um, so, but as we look at the report, something I really like to stress for producers is not just looking at protein and energy requirements versus the protein and energy on the report, but also what are the characteristics of that forage? How much fiber is in there? Is that fiber digestible? And then, of course, I'm a big proponent of mineral analysis on forages as well. But how much fiber, how digestible it is going to play a huge role in how that fiber is going to interact in the rumen, in the gut, and how that actually is going to match to animals' nutrient requirements, and then therefore the supplementation strategy that you need to have. So ultimately, when we're comparing, our browsers are going to be a lot more selective. They're going to have a higher variability in their diet, more leaves, more berries, things like that. I read somewhere that, like, think of pronghorn, they can survive on leaves from sagebrush, right? That's pretty incredible and pretty amazing that they're not getting all the fibrous twigs, right? Relative to a cow that, would not have the ability to do that. So in addition to the grazing behavior, there are also some other things that impact their nutritional requirements, which is fleece production. Are we producing them for meat, for milk? And then if they are reproducing, singles versus twins, small ruminants have the ability to produce twins more so than beef cattle do, right? So now we've somewhat covered the comparative anatomy between understanding why sheep and goats are truly a different animal than a beef cow, even though a lot of the literature when it comes to understanding forage reports is geared for a beef cow. So now I'm going to go through understanding the actual forage report, and we're going to go through each fraction and each piece so that we really get a good knowledge and understanding of what's being represented on the report. And then finally, we'll go through the report and see what it means for our animals. Okay, so the first fraction we want to look at is dry matter and moisture. So typically, when we're talking about hay, people are very concerned about dry matter and moisture, thinking if it's too moist, then we have the potential for spontaneous combustions and, of course, fire. So that's our number one consideration. So in order to avoid that, we need the moisture to be less than 20% approximately. But what we've also found is that we also need to reduce mold risk and mycotoxin risk, especially, I don't know how things have been in Western states. In Nebraska, that has been a huge issue this year. Heat damage as well, even if it didn't spontaneously combust when we have too high of moisture. So that kind of thing occurs between 18 and 22% moisture, but between 18 and 14% is going to be optimal. If it's less than 14%, then that hay is really brittle and it's a lot more, you're going to lose a lot more of the leafy material. And so, you're going to see a lot more of that lying on the ground rather than getting into animals' bellies. Um, so then the next portion is ash. So we've got the ash and then the organic matter. So ash is the total elemental content of the feed. Plants typically have 4 to 6% ash. Hays should have between 8 and 10. Over 10% indicates overraking and soil contamination. And so soil contamination can also coincide with high iron levels too. So I like to look at those two numbers together, and we'll kind of get to that. But in extreme cases of soil contamination, um, you can see it will reduce animal intake. And in addition to reducing the animal's intake, it can form blockages. And so it can become an animal health issue when it's really high. So minerals are actually what's making up that ash, right? And so, so ash, we want it at a lower level, but it's also really important to make sure we are getting those minerals into the animal through the forage. And so minerals are important cofactors in different biological functions, maintenance, growth, reproduction, in the case of, wool, sheep, wool production, that kind of thing. And so, here are some of the key minerals in fiber production, but it's always a careful balance, right? So zinc's important, copper's important to fleece and wool production, but we have to make sure it's in a balance because molybdenum can interfere with copper, so it's just an antagonist. But sulfur and iron are important for biological functions, but yet, including in fiber production, but yet they can also interfere with copper. So we have to make sure everything is in a balance. And this is not a mineral talk. We could talk about this for days. But so here's kind of the basic minerals that can be analyzed on a lab report. And so you can kind of see here, just looking at those minerals and the potential interactions with those. But ultimately, there's even more minerals out there that we aren't analyzing, we aren't monitoring. So there's all kinds of mineral interactions at play within the diet of any animal. So minerals also can be very variable in forages. So this is just an example of manganese. So what we have on, and I should have changed this because this is actually maximum tolerable level and requirement for a beef cow. So essentially what you can see though is we've got the percent manganese on the y-axis. The x-axis is different forages that we were evaluating based on producer submitted forages. And you can see some samples meet requirements, some samples are below requirements, and some are even above the maximum tolerable level. So we have to be careful. We don't just want to be throwing out a high mag mineral to animals, when we aren't being intentional and understanding what's actually in the forage that we're feeding, right? And so then this is kind of the same thing. This is a paper from Nebraska beef using our data. And the point of this is, so this was the gray shaded boxes are minerals that need supplementation in various forages at various forage quality levels. So we have alfalfa, we have perennial grass, annual small grains, warm season grasses, and corn feedstuffs as well. And it was which ones are deficient in the forage if we were feeding a 1,200 pound, I believe it was lactating beef cow. I don't recall. But the point is you can see most forages, and it's going to align with, your sheep and goat requirements as well. But most forages are lacking in zinc and copper. So at a bare minimum, if you're not supplementing anything, a trace mineral salt with that zinc and copper is going to be key to make sure your animals are healthy and can produce, wool and reproductive performance, all of that. So just a brief side note for lab analysis wise, I always recommend that minerals be ran wet chemistry and not by NIR, but the rest of your forage report, absolutely run NIR. That is my recommendation, and it's very accurate, very concise. If you have questions about that, I can answer more in detail. But what we've got here is on the y-axis, so we've got calcium, potassium, phosphorus, and magnesium, so 4 major macro minerals. And then on the y-axis, we have NIRS Forage and Feed Testing Consortium predicted values based on their calibrations. And then we've got our wet chemistry values on the x-axis. So that red line going across, or maybe it's orange, that's the 1-to-1 ratio. So if this was a perfect prediction equation, then all those dots should be falling right along the line. But you can see then the other line on there, the blue line, and then you can also see that there's a large spread. So basically, these minerals, they're not detected well using the NIR technology. But that's not to scare you off from the NIR technology. So here's another, and then we're going to get into the macronutrients. So we've got at our lab, our guarantee to make sure we're always producing accurate, reliable results is if you run NIR and it produces either bad global H or something about that sample just doesn't look right to you, we will, which global H is just a statistic that we look at in-house. So we do this before ever sending you your report. We will run protein, ADF, and NDF wet chemistry at no charge. And so what you can see is that when I did the same comparison that I did with the minerals on the outlier samples, and it should be noted, the minerals, that was done on samples where producers requested both wet chem and NIR. So anyhow, R squared, you want that as close to 1 as possible. That would be the samples falling right along that 1-to-1 line. And so as you can see, even samples that are saying, oh, we're not a really good fit, actually for protein and fibers, it's very accurate prediction, even when it's saying, maybe not so much. Then when we look at our NFTA samples, so if you're not familiar, National Forage Testing Association, that's our certification group that we are a part of, and we submit samples every year and compare to other lab results. And we're certified in NIR and wet chemistry now. So you can see those are normal samples. So they should be falling in line. So no surprise, calcium and fibers both look very good. Excuse me, I meant to say protein. Calcium actually looks really good, but you can see phosphorus, magnesium, and potassium not as great. Potassium is not bad, but we also have to think about the average relative bias is not great on that one either. And then obviously it's not good for calcium either. And then when we looked at the producer samples, so the slide I just showed you before, you can see the R square is pretty far off from 1, especially looking at phosphorus and magnesium. Okay, so that's my soapbox on why you need to ask for NIR plus minerals, ran wet chemistry, and not just rely on those NIR data points. So moving on. So the reason why we're even analyzing those minerals to begin with is we want to compare what's in our forage to what the animal nutrient requirement is, and then we can make a really good decision about what mineral to be feeding those animals. So this is just the sheep and goat maximum tolerable level and requirements from NRC, and it is found also in the ward guide on this compiled table here. Okay, so now getting more into the macronutrients. So we're under the organic matter umbrella, and we have neutral detergent fiber, and then we have neutral detergent solubles. So when we run a fiber analysis, it's kind of like a washing machine. So we're washing out everything that's not fiber. So when we run neutral detergent fiber, these are the things that are washed away. So the first one is fat or ether extract, then crude protein we're going to go through, and then non-fiber carbohydrates. So fat is really important when we talk about any animal's nutrition because it's going to be that delivery agent for vitamins. And forages typically are not, oh shoot, I thought I closed that, are not super high in fat, obviously less than 2%. We don't expect this to be a big fat source, but we do expect it to be a decent source for vitamins, especially vitamin A. Uh, Crude protein. Okay, so I'm not going to get into all the slides I put together on this, but I do want to talk a little bit about understanding the difference between crude protein and true protein, and then the rumen metabolizable protein system. So animals do not actually have a requirement for crude protein, even though what you see in all of the books in the NRC, and that's even what I'm going to go off of, is the crude protein recommendation. But what they really need are amino acids. And so amino acids are the building blocks of protein. Um, and you can see here, and you might remember this from like your biochem classes and stuff. The point is that these form the ideal protein, which is the right ratios of amino acids are going to provide the animal with the ideal protein that they need. And this is where we get the concept of wanting to feed rumen protected amino acids and getting specific amino acids into the animals. So that's something that's kind of coming around in the cattle world. I haven't seen much in sheep and goat, but it may be coming down the line, right? Because it kind of follows. So again, those amino acids link together. They form this big folded structure, and then that is what makes up crude protein. Well, what we're actually measuring on that crude protein is the nitrogen group on those amino acids, and then we multiply by 6.25, and that's our estimate for crude protein, and that's the best that we have right now for understanding that animal's protein needs. So this is what most rations and diets are going to be based on. And then, like I said, so this year, especially with in Nebraska anyways, I don't know how your guys' seasons were. But we had a lot of rain, especially when we were trying to get stuff baled up. And so this year, the heat damage protein has been a real challenge. And so we are encouraging producers to go off the adjusted crude protein when heat damage protein is pretty prevalent. So essentially what happens with the heat damage protein, it's in that bale, it's hot, the moisture causes the Maillard reactions to happen, and then those reactions then bind protein to the lignin and the ADF portion of that plant. So it's not available for the animal to actually, it's just going to pass right through. So then that's why we focus on the adjusted protein so that we're saying what's the animal actually getting. And then insoluble and soluble protein. So this is a system where a laboratory extract is used to simulate rumen digestion. And this actually is not currently on our reports, but it is something you could request if you were really getting into it. But this is what you would need to estimate the rumen degradable protein and rumen undegraded protein in order to balance off of the metabolizable or true protein system. And so basically with this system, it's saying what amount of that protein is passing through the rumen that's coming directly from the feed, what amount's getting degraded and used by rumen microbes. And then when we feed ruminants, we can feed non-protein nitrogen, and how are they utilizing that? So that's kind of what this system can do. Okay, so non-fiber carbohydrates. So if you see this as a calculated value on your report, it's just 100 minus protein, fat, ash, and neutral detergent fiber. And it includes the starch portion of your forages. as well as the ethanol soluble carbs and water soluble carbs. And of course, there's some overlap with ethanol soluble carbs and water soluble carbs. So with sheep and goat nutrition, this isn't really a huge talking point other than we do want to look at it and make sure we're not going to be at risk for like acidosis when we're looking at like a high starch feed. But most of the non-fiber carbs diet nutrition forage report stuff goes for equine nutrition. So I don't worry about it too much. Okay, now looking at neutral detergent fiber, the first thing we're going to look at is that hemicellulose. So first, I kind of explained neutral detergent fiber is basically we put it in a washing machine and we're pulling off the the fat, the protein, the non-structured non-fiber carbohydrates. And so this represents the slowly digestible portion of the feed as well as the indigestible portion of the feed. So that's going to include cellulose, hemicellulose, and lignin. Okay, and so the more lignin and the more cellulose that's included in this, then the less digestible NDF actually is. And I think that's my next slide. Yep. So when we look at this value on our report, we're also going to want to look and evaluate the digestibility of it. And so, but before we do that, when we talk about beef cattle, as NDF starts to approach 60%, we start to get concerned that intake is going to be inhibited. So meaning that animal is not going to consume as much of the forage. Now, when we're talking about sheep and goats, and we remember their natural grazing patterns and strategies, and we remember that they are not able to tolerate as much fiber. So we don't have like a hard number like 60%. But what we know is we for sure don't want forages around 60%, and we probably want them closer to having an NDF below 50%. But we're also going to want to evaluate that with the digestibility. So looking at this table, so NDF digestibility, typically I say average is about 45%. And you can see that and our reports are always looking at 48-hour. There are other labs that will report 30-hour. We have the 30-hour data. We just don't report it. The feedback we get from producers is just there's a lot of cluttered numbers already. So we just chose one to go with. So when we look at the 48-hour digestibility, you can see there's high, medium, and low digestibility, and it's variable across different feed types. So that first one, alfalfa hay, is 44, is considered lowly digestible. And then 55 is considered highly digestible. I mean, I've seen reports that have 60 on it. Yeah, that grass hay there, 64%. And so a lot of times taking into account the digestibility of the fiber is going to impact how it interacts with the animal as well. So the higher digestibility of that NDF, the less worried we need to be if we see a high value of that NDF. Okay, so then the next part is acid detergent fiber. And so this is the least digestible portion of the feed. So this includes cellulose and lignin. It does not include the hemicellulose. So the hemicellulose, that's when we're talking about digestibility of NDF, we're talking about digesting that hemicellulose portion. So lignin's the most indigestible compound. It's going to be really, really high in things like straw, right? And so the higher the lignin, the less digestible. So that's why we have things like low lignin alfalfa varieties. And then with ADF, so we have different ways of calculating animal energy. When it comes to forages, I've already been saying I recommend an NIR analysis. Part of the reason for that is because of the cost. And then the other part is that you can use a summative equation to get to the TDN values. And so for sheep, small ruminants, we do use the same TDN value equations as for beef cattle. And so for our lab, legume hay, grass hay, and corn silage, which is not up here, we can use these summative equations, which is going to take into account all different aspects of the forage, from the protein to the neutral detergent fiber digestibility that we talked about being really important. So I think it's a little bit better representation of potential energy value of that forage. Whereas sometimes in some producers and some labs, even with NIR, if we don't have the ability to run NIR, we can run protein and we can run ADF. And then ADF is the only value used to determine TDN. And so that's where sometimes if you get an unexpected TDN and it's on a wet chemistry report, the first thing you should look at is, well, where is that ADF? Is that where we expect it to be for this feed? And kind of double checking those kinds of things. But we have different equations based on different feed types. But it's all just based on that one parameter. So ultimately, I prefer the summative equations. There are other people who prefer just the ADF equations. And then nitrates is something that I always just like to mention. Sheep and goats are ruminants too. They're just as susceptible to nitrate toxicity as beef cattle. So we want to always be careful about that. And that's something that we have the ability to test and something that you commonly do see tested in our lab. But yeah, okay, so we've gone through all these different parameters, right? So think about all those slides I just shared with you, and all that probably seems like a lot of too much information. So here's our forage report. So the first thing we're going to look at, right, is the moisture. So this moisture was at 7.58. So if I'm looking at purchasing this, that doesn't really affect too much other than how that compares to the other forages available to me. But if I'm the producer for this, if you're producing your own hay, that shows that there's room for improvement as far as keeping things moist. It was probably over dried. We want that to be, what did I say was optimal, around 14%, right? To make sure we keep that leafy material. And then our next value we're going to look at is crude protein. So when we start looking at crude protein, the first thing we need to do is look at what's our animal's requirements. So I looked up 150-pound ewe suckling twins. So her requirement for protein is 14.8%, and her TDN requirement is 64.5%. Okay, so we look at this compared to the dry basis report. 11.4 is less than 14%. So that does not meet her requirement. So we know right off the bat, if we're feeding this hay, we're going to need to do some supplementation of protein. Okay. And that moisture was very dry. So this is probably a dry brittle hay, but that also shows that heat damage protein, that second value under that protein, it's not enough to warrant using the available protein. So that's a good thing. So we don't have any heat damage. So now the next thing under my carbohydrates header there, I'm looking at fibers. So I have ADF and I have NDF. And both of these are actually in a good range. They're not too high to where I'd be too concerned. And then I look at the NDFD 48-hour digestibility. I just like to skip down there, see if I can. So the 48-hour NDF digestibility is 64. So when we recall the chart previously, that's really highly digestible forage. So I'm not too concerned about affecting intake or anything like that. And then lignin at 2.84, that's pretty darn low. So that's really good. And then I should have mentioned, I believe this was a grass hay report that I pulled. So starch is low, non-structural carbohydrates, that is also actually pretty low. So while we don't have fiber issues, all of these are kind of things that contribute to the energy content of the feed. And you could see 58.4. For most beef cattle, that would be great. But for a ewe with such high demands, suckling two twins, twin lambs, that's not going to meet her 64% energy. So let's see. Yep, there we go. And then of course the fat was pretty low. And then our ash is at 9.89, so we don't have soil contamination, so that's great. So then the next thing we're gonna do is I pulled up mature U requirements. So this is like the ideal range here for these forages or for these minerals. So we're just gonna compare. So first looking at calcium, so it's at 0.3. Um, with this range here for mature ewe, when they're lactating, that's typically the peak of their requirements. So even though 0.3 is within that range, I actually would like to see it closer to 0.4. And then maximum tolerable level is 1.5%. So we have lots of room to supplement some calcium there for her. So now phosphorus 0.27. We look at this table here. Again, that's 0.3. So we're just shy on phosphorus. And then we also, when we're looking at calcium and phosphorus, we want to think about the cal-phos ratio, keeping that between 1 and 2. So potassium, 1.93. Our potassium upper range is 0.8. So that did meet requirements. Magnesium, 0.2. So our upper limit for or upper range that we want to see for magnesium is 0.18. Sulfur 0.23. Let's see what their table says. Sulfur, so 0.25. So I would maybe like to see a little bit more sulfur, but I did say it meets, I guess, when I was doing this. So but we have wiggle room. So the max tolerable level for sulfur is actually, oh, that's why I put the wrong values in this. It's actually 0.3. So, yeah, we actually want to be kind of careful on that one. Um, and then sodium, I know that's not going to meet it. We need to be supplementing salt. We never expect our forages to meet the sodium. Copper, we know we need to be really careful with sheep, so 6.5. We want that to be 10. And we know sheep are very sensitive to copper, so we have to be really careful when we're supplementing this. Iron, it's below 250 parts per million, but above the recommended 40, so that's good. Well within our ideal range. Manganese, same thing, above 40. I should, going back to iron, I said below 250 because that's at the point where it starts to interfere with copper absorption. And so where we already don't have a lot, we don't want to see much there. And then molybdenum, uh, sheep are the only animals that kind of have that requirement. This is 0.49. I'm saying with lab error 0.5, it's exactly where we want it to be. And we don't really, sheep have the requirement for it because it's tying up that copper. We don't have excess copper, so we want to be careful of that. And then our zinc is just meeting the requirement, 30 parts per million there. Okay, so our conclusion, going through and looking at that report, is that we need protein and we need energy supplementation and we do need a mineral. So once you've got your forage tested, I can do a consult with you and go through your report just like we just did with this one. If you have a feed stuff that you're planning to supplement, and I think I would assume that your extension agents also could help you with these kinds of things. And then formulating that supplementation strategy and helping choose a mineral, those are things that I can help you do. And I'm sure Melinda, Chad, Carmen, I'm sure they all can also help you with those things, work through those things as well. But basing it on your forage report just helps because that way you know for sure your animal's going to be getting what they need. And you're not going to be spending more than what you need to be spending. Make sure everything's balanced. And like we said earlier, going through the minerals, everything needs to be in a good balance because there's so many different interactions that can happen. Okay, so that was understanding the forage report. That was the meat and potatoes. So We kind of breathe a sigh of relief. We're almost through it. So the next thing we're going to talk about is understanding a water report. And I'm not going to go into as much detail as I did with the forage report. So water analysis for small ruminants. So the reason I really wanted to bring this up is because Ward Labs has actually been working with the um, North American Pack Goat Association um, for 3 years now, I think going on 4. Um, so water analysis can be really important for small ruminants, and it goes hand in hand with your forage analysis. So they were having issues in their group with urinary calculi. And so this kind of goes back again to some more comparative anatomy and physiology. When we look at a goat or a sheep, they have this sigmoid structure. And so it's not that they're more prone to accumulating calcium stones in their bladder, it's that they're more likely to have them get stuck. And then they also have this urethral process, which is another place that they can get stuck. And this, the first producer I worked with on this, I mean, he lost goats because of this. And so that's kind of how we got involved with this project. So they've been working on this urinary calculi research project. They've been having their producers send us their water samples as well as their forage samples for 3 years. So here are just some kind of the main takeaways from what they learned over the past 3 years. Most of the stones were calcium carbonate stones. So when we go through the water analysis, that means we definitely want to make sure that our goats and our sheep do not have hard water. And we need to make sure of that. And then forage samples are variable in protein and calcium and phosphorus. That's a huge reason to test alone, let alone balancing their nutrition. Um, and so water intake is key to make sure things are dissolving. So when we talk about any livestock, we want to make sure that they have a clean, fresh, good water source. So I'm not going to go over the rest here, but I would really encourage you. This original article that I shared here, this was written by Chris Gifford and Taffy Mercer. They've been great to work with. I believe it was in Goat People magazine. So, but you can find it on their website, on the North American Pack Goat Association website, as well as more information about the study and who's involved and what they're all doing. So it's really interesting stuff, and we've had a great time working with them and analyzing their samples for them. And we've even had one producer come up, bring his sample in person so he could tour the lab. So, and I've done a lot of consulting with different goat people because of this. So, looking at our water report, so I'll tell you right off the bat, I probably should have looked a little harder to find one that has issues. This water report doesn't have a lot of issues. So, I have compiled the ward guide, livestock suitability analysis guidelines, and it's everything I could find through all the NRC resources, beef, cattle, small ruminants, poultry, everything to come up with these guidelines. And so you can find that on our website. I should have put a screenshot of it here. If you're ever trying to interpret Oregon, you can just call me, or I'm sure your extension agents can help you. So first thing we're going to look at on the report is the pH. So we want it to be within a biological range, right? So 7.5. This is the ideal range right here that I pulled off the ward guide. So that looks really good. This EC and cation anion balance, these are kind of quality control. So you want them to be pretty similar. So 0.8 and 0.7, that looks good. So then TDS, total dissolved solids, is the next thing that we actually have guideline for. So less than 3,000. So this looks great. And then sodium needs to be less than 800 for ruminants. So this is really low, so that's great. Potassium, okay, we skip over these minerals because we don't have good guidance specific to water. But I will say I have worked with some extension agents and programs. They were for beef cattle, but there are people out there who know how to handle them if these things get too high. Obviously, this report, everything's pretty darn low, so I don't worry too much about it. The total hardness here was 29. The ideal range is going to be 0 to 60. I have seen this value very, very, very high on total hardness. And for our pack goat producers, they're somewhat like pets. We've actually had people I've talked to who have installed water softeners for their barn. So that's pretty interesting. I'm not saying every livestock producer would probably do that, but the level of care for these pack goats is very, very high. So the nitrates obviously are very low. We want to keep those under 20. So again, I did briefly mention nitrates when talking about forages. If you do have a high nitrate number in your water, you need to be extra cautious with your forages and what nitrates are potentially there. Sulfates are very, very low here. If you do get into a situation where you have high sulfate water, that's where you're going to start seeing animals kind of showing like staggering and head pressing. They call them like brainer cows, stumbling when they walk. So be careful of that. But that is pretty much everything to go through on that forage report. Phosphorus is another thing that can cause urinary calculi. Obviously, majority in the study is not where that came from, but if this value is high, that can be an issue as well. I just wanted to mention. So we've kind of gone through it all. We looked at some different grazing behavior, comparative anatomy. We understand now that when we look at our forage report, we want to look for, what are the animal's requirements? We want to meet those protein and energy requirements. We want to make sure that our fibers are lower than what we might accept for beef cattle. And we also understand that we might have to do some more supplementation of other unique feedstuffs based on that. And then we understand how water and forages both play a role, and testing them both and making sure everything's in balance is very important. So with that, I just want to say thank you to Melinda and Carmen for asking me to come on. And here's my contact info. I'll leave it up for, I guess, if anyone had any questions.
Thank you so much. That was such amazing information, and I feel like we don't get it out as much as we should, probably. So hopefully you all gain some information that you can use in your operation now. We do have a few questions. One is just simply, can you share the link for the requirements that you had in your presentation there? Or maybe we can figure out a way to send that out in our email list or something like that.
Oh, for the on the forage report, yeah, I can. I can send it to you, Melinda, afterward.
Okay.
I'll make
Yeah.
a note.
The second question we've got today, and just a reminder to everybody, please go ahead and put all your questions in the Q&A, and we'll make sure to get those addressed as well as we can today. The second one is, do you test for iodine in water? This person has seen issues with iodine levels in milk when the water table has dropped. So,
We actually don't. That is one that we send out. We send iodine to SDK labs in Kansas, but we would send to any lab of anybody's choice, but we don't. That's not one that we can run in-house, unfortunately.
okay. And then how often do you recommend doing testing on your water?
Yeah, that's always the good question. So it kind of depends, right? So it depends on the circumstances. If you're on a municipality, typically they have water tests that you can look at. Where to go find them, I don't know, but once you test that one shouldn't change much. If it's a well, the recommendation is about every 3 years, unless you have an event. Like, so in around Kearney, we had a big flooding event, and so we had a lot of people testing wells after the flood, just to make sure everything was fine. And then if you just notice anything weird smells or weird colors, then obviously that's a good time to go ahead and test, even if you happen to have tested the year before. Something may have happened there.
And then This participant was wondering if you also do soil samples in-house.
Yep. So Ward Labs was started as a soil sample lab. So that's the majority of our business actually. And we get samples from all over the world for soil sampling. We have a soil health analysis that they are really pushing right now that looks at physical, chemical, and biological components. We have just the regular traditional soil samples that we've always ran in-house. So I think this year our sample volume for soils is like 300,000 some, and we get about, between 20 and 30,000 for feet in NIR. So if that kind of gives you an idea, we do a lot of soil.
Perfect. So just really quickly, I've had a couple of people ask about getting some of the slides or a PDF maybe of your presentation. Maybe we could do that.
Yeah, I'll send
Part
that
of
to you.
okay. And then just as a reminder, this presentation will also be posted to our YouTube channel, the University of Idaho Extension Livestock channel. So you can also go back and rewatch it as you would like. Do you have sampling kits that you can send out to people?
Yes, we do. So actually, you can go in and order online if you're only going to be sending a couple of samples. You have to, choose your test package and kind of know what you're doing, all of that. And then we will send you a bag and a mailer. If you want to do it that's prepaid. Otherwise, you can just send on our website. We do have a submission form you can download, and then you can just send it in a regular Ziploc bag if you fill that out, and you don't have to wait for us to send you anything. So
Perfect. And remind us how long you have with a water sample from the time you collect it to the time it gets to you, and how do you recommend shipping that?
Mhm. So for the report that I showed in this presentation, that was livestock water suitability. Everything we're measuring there isn't going to change. So there's really no time frame on that. Um, if you are experiencing issues where you think a bacteria test is needed, that's where you need a special bottle. So I would definitely recommend calling the lab, and then it needs to be taken and then overnighted to the lab and it has to arrive between Monday and Thursday, and I believe before 3 p.m. So that would be the only one that has a time frame, but just a standard livestock quality. Just take your sample, you can put it in the regular mail, it's going to be just fine. With that, though, I would say if you're packaging your sample, tape the lid because we do have lids pop off. Don't send it in a glass container. We have people who do that too. Most of the time they get lucky and they're fine, but sometimes they're not. And then just put it in a Ziploc bag as well. That way, if your bottle does break or your lid does pop off for some reason, usually we can still salvage it.
Perfect. So this question is coming from a person in Mississippi, and they say, as hot as it gets there, can we assume that a lot of our hay may be damaged from the heat, or are the grasses in that part of the country different?
So when I say heat damage, it's not actually like the temperature, right? Like, um, and in Mississippi, obviously, I know you guys have a lot of crazy humidity as well. Um, so it's more of the moisture in the hay. I'm not a chemist, and so I don't know if I can't explain it right. It's called a Maillard reaction, but it's the moisture in the hay interacting, and it's causing heat within that bale. And so it's really the most important part of that is just making sure your hay is at a good dry level. So less than 18%. That's the best way to prevent the heat damage. You're not going to get heat damage just because it's hot outside. Um, in southern states, when they do have difficult times with humidity and rain, there you'll see a lot more haylage being produced down there because that eliminates um that management concern. Haylage can still have heat damage, But when it's done properly, it's not as much. It can preserve the quality a little bit better than hay that's not in siling, if that makes sense.
Perfect. So this question is kind of interesting. It'll be interesting to hear what you have to say about it. But this person has a pending contract to do some targeted grazing where there was a dump site, so it was set aside as unsalable or undeveloped since 1976. So they're curious what types of testing you might recommend to make sure that it's actually safe for their sheep, goats. They didn't say sheep or goats, but
A
what are your
dump,
thoughts on that?
I guess what a dump site dumping like trash or
I don't, if you have a response to that, Jeff, is it trash or is it like a mine site or what type of dump site are you talking about? But I guess we could probably just go with one or the other
so
things.
depending what it would be. So like this is kind of a weird thing to think about, but when I was an undergrad, I did an internship monitoring birds where they were mining and they were dumping the tailings into the water. And so selenium was in those tailings. So depending what was being dumped there might determine what testing you need. So it could be a heavy metals issue, and that definitely could be taken up by grass. So you may need to run some heavy metal testing in addition to your standard nutritional testing. If it's really just like a dump, like that people were putting trash and then it got buried over. Um, I'm not even sure, on that one.
So Jeff said that they're not sure what was dumped there. He'd be grazing goats. My thought process there, Jeff, would be maybe reach out on an individual basis and we could talk through some of those things, whether you reach out to me or Rebecca. Um, we could help you with that in more detail once we have a little more information.
Yeah. And
Uh,
we actually have, if it is, depending if we could figure out the history on it, Dr. Patrick Fries is actually like a reclamation expert. And he is on our staff and he's actually out west. So, um, he might be one that we could loop in on that too to see what he would think.
Perfect. That'd be great. So Jeff, reach out to us. That'd be a fun project for us. So I'm going to take two more questions. One, the question is the normal rumen microbiota susceptible to disruption by chlorine when it's introduced through drinking water or other environmental exposures? And if so, how would you manage for this?
Oh, that is a question that I have never encountered before. So I can't answer that based on experience. If you were to call me and ask me this, I would definitely have to do some research. Melinda or Chad might have a better answer for that. I would say I've never encountered a high chlorine water source for livestock. Um, so
Yeah, truthfully, I don't have a great answer either, but the things I do know about chlorine is unless it's being added regularly in some fashion that's in a toxic level, it does dissipate out pretty quickly. So for example, if you shock your well or something like that, um, it'll dissipate out and you don't have to worry about it. I don't think that you're at risk of a bad toxicity exposure unless it's being regularly added to the source. So if that's the case and it's above the levels that it should be, that's something that maybe you would want to reach out and we could do some more research on. Um, the last question that I'm going to get to today is what is the process if somebody were to want to work with Ward Labs for research or education projects or grants, that type of thing?
yeah, the first thing would just be to reach out to me or one of our key account managers and start with a quote. Tell us, how many samples are in your study, what testing are you wanting to do? We can get you a quote. We do offer research discounts and we do support research and education. And so that's the first place I would say to start. And then depending what your project looks like, it's going to be different, right? So like if it's a university researcher, they'll send us a big batch, and then we'll, run it alongside producer samples as we can. Otherwise, like the UC Goat Association, we sent out massive kits to a bunch of participants in their studies, and then we just run them as we receive them. So it's really just going to depend what you're doing. And so just shooting me an email is probably the best place to start, I'd say.
Perfect. So with that, I think we're going to wrap up just for the sake of time. But thank you so much for this presentation. And a number of the comments were wanting to thank you and telling you how great of a webinar it was, that they hadn't attended one like it in a long time, that type of thing. So you're getting lots of praise and feedback. And to all of our participants on the other end, we sure appreciate you every time that you join us. It really helps make our job easy to have you here and have you stay active in our programming. So, Merry Christmas, Happy New Year, and we will see you again in January.